In this video, we're looking at practice 30, which is called Solve Equations and Inequalities. Practice 30 begins on page 14. So I'm going to shortcut my turning to page 14. If you have not watched the video on this, please do that first, the lesson video, and it will teach you how to solve both of these. Number 1. Which three sets of numbers can be substituted for x in the inequality to make it true? Now, I could just substitute numbers in there, but it is much faster to solve the inequality. So let's do that. We know how to do that. It's actually a pretty short solution. Here's your constant, and here's your variable. So we are going to divide both sides by 3. And I'm left with 9 is greater than or equal to x. I want to standardize that. So turn everything around and graph. If you want to graph, you don't have to. But I like to graph because it shows me what my interval will be. So 9 and below. A would fit 9 and below. B would fit 9 and below. C can't because 10 is bigger than 9. But D fits 9 and below. So A, B, and C are all correct answers to number 1. E and F both have things bigger than 9, so we can't use those. Number 2. Veronica makes 135 necklaces to sell at a one-day craft fair. This is 75 less than she makes to sell at a 2-day craft fair. How many necklaces does Veronica make to sell at a 2-day craft fair? So they're telling me that the 1-day craft fair is the 2-day craft fair minus 75. 75 less than the 2-day craft fair. So the 1-day fair is 135. We don't know the 2-day fair, but we can find it by adding the 75 to both sides. This is not an inequality. This is an equation. It's an exact amount. So I'm thinking 210 necklaces for the 2-day craft fair. Number 3. Cindy buys 3 red peppers at the store. This is a third the number of green peppers that she buys. How many green peppers does Cindy buy? Well, the red peppers are 1/3 of the green. So red, we know she bought 3 of those, and 1/3 of means 1/3 times the green. So here's the equation that I need to solve, and I'm going to do that by using the reciprocal of 1/3. Remember, I have to do it to both sides. So I have 9/1. So the green peppers, there are 9 of them. That is an equation. It's an exact amount. It's not greater than, less than. Number 4. Stephen has $45. Which set of items can he buy? 5 movie tickets that cost $10. So 5 times 10, that's 50. So he can't buy those. 6 coffee mugs that cost $7 each. He could afford those. 9 hamburgers that each cost $6. He could not afford that. Or 12 water bottles that cost $4 each. I think he could afford to buy the coffee mugs. And he would still have $3 left over. Number 5. At a department store, plates are sold in boxes of 8. Which equation or inequality describes the number of plates in 6 boxes? So let's represent this one with a little picture. Here is a box of plates and it has 8 plates in there. If we want to buy 6 of those, and I'm going to put them all in here, let your brain think about what I'm doing here. I am making the same box over and over and over. I am multiplying. So we are looking for a multiplication equation. This is not an inequality. This is an exact amount. So we can eliminate these two. A is saying 6 times the plates is 8. That's not what we want to say. We want to say that the plates would be 6 boxes that have 8 in a box. So C is the answer I want for part A. Part B, Stacy buys 72 plates for a party. How many boxes of plates does she buy? Well, if she buys 72 plates and those plates are in boxes, that's 72 divided by 8, and that is 9 boxes. Again, that one is an equation, not an inequality. Number 6. Dwayne works 7 shifts in a pay period. Each shift is 8 hours long. How many hours does Dwayne work? So we know that he works 7 shifts and that each shift is 8 hours long. We don't have to set up an equation. We can just multiply that one to get the answer. Number 8. Which set of numbers can be substituted for y to make the inequality true? Well, I'm just going to solve the inequality and then I won't have to substitute all of those numbers. So I'm going to set this as the constant side and this is the variable side. Add a 7 to both sides. So we have 30 and 5y. Divide by 5. So y is less than or equal to 6. I want to standardize and graph because then I can see that interval very clearly. 6 is included and it's less than or equal to 6. So anything in this interval is acceptable. It can be 6 or below. So D is the one we want. We can include the 6 and we have to go below the 6. Number 9. I had put a piece of paper in there in case I needed it. But Jessie is packing for a trip. The maximum weight for a carry-on bag is 35 pounds. So let's draw the graph of that. It can be 35, but it cannot go above 35. It has to be 35 or less. So the inequality would be the weight of the bag is less than or equal to 35. And then they want us to pick the inequality that matches. I like this one. We've already got it set up. It is in standard form, so you're good to go there. I would go with A. Which 3 are acceptable weights for Jessie's bag? Remember, let me pull the graph down here so you can see that. It has to be 35 or less. So I would say A, B, and C. 35 or less. Number 10. Which set of numbers can be substituted for m in the inequality 4m is greater than 12 to make it true? So 4m greater than 12. I would just solve it and then you'll know. Once you solve it, you can make the graph and you can see the variable and the constant. Divide by 4. So whatever value you use for m, it has to be more than 3. Can't be 3. Has to be more than 3. So if you graph it, can't be 3. So we leave that open and go above it. I like D. It could be 4, it could be 5, or it could be 7, as long as it is above the value of 3. Number 11. A train ticket costs $57. The ticket costs $10 less when it is purchased at least 1 day in advance. Brian buys a ticket 2 days in advance. So how much does the ticket cost? Well, if it's $57 and you get the discount, that means that he paid $47 for the ticket. Don't overthink these. Some of them really are just basic math. Some of them are not basic math. But if you can get by with basic math, go with that. Paul has 8 tables that each seat 4 people at his restaurant. Which inequality represents the number of guests, G, Paul can seat at any time? I'm going to draw this one for you. Here's a table that can seat 4 people. How many of those tables does Paul have? 2, 4, 6, 8. I'm doing this to show you the value of drawing a picture. If you're on a problem and you just cannot figure it out, try to draw it or try to use some other strategy to get the picture to be clearer to you. So we have 8 tables with 4 seats. So at most, he could seat 4 times 8, and that is 32. So he could never go more than 32. He would have to seat 32 people, and we can seat 32. We've got enough seats, but he could not go over that. He would have to go less than that. So the inequality that you want is D. We can seat 32 or below 32 guests, and that's what the G is. At 32 or below. Okay, number 13. Renee can put 6 photographs on one page in a photo book. So you know what I'm going to do. 1, 2, 3, 4, 5, 6. This is one page. Which equation or inequality describes the number of photos Renee can put on 12 pages? So 6 times 12, 6 on one page times 12 pages is 72. But that's not what they're asking me to do. They're asking me to set up the equation or inequality for this scenario. Well, first of all, I know it's not an inequality because there are an exact number of photos. So it could be A, 12 times 6, or it could be 12 times pages equals 6. It's not equals 6, it's equals 72. So I would want to go with A on this one. How many pages does Renee need for 54 photos? Well, if you have 54 photos and each page looks like this, we are dividing 54 up into pages. So 54 divided by 6 is 9 pages. Sometimes a picture's worth 1,000 words. For me, some people don't like pictures, and that's okay too. You don't have to draw those. Trevor plays for 8 minutes in a basketball game. This is 1/4 of the total game time. How long is the game? So Trevor's time is 1/4 of the total time. And Trevor's time is 8 minutes. So 8 is 1/4 of the total. To solve this one, we would say 4 over 1. Use your reciprocal, and you end up with 32 over 1 equals T. So the time was 32 minutes. And number 15. A large first-class envelope can hold a maximum weight of 13 ounces. Maximum means it's the most. So 13 ounces is the most you can put in that envelope. The weight must be less than that. You can put 13, but anything higher than that would not be okay. So the weight is less than or equal to 13. I like B for this answer. And then part B, which of these can be mailed in a large first class envelope? So let's pull this down here so we can use it for this part also. A book that weighs 17 ounces. 17 would be up here. A bag of nuts that weighs 32 ounces. A photo album that weighs 20 ounces. Or a singing greeting card that weighs exactly 13 ounces. Only one of those would be D. All right, that brings us to the end of that lesson. I'm going to go ahead and delete that page. I thought I might need it, but I don't. And I will see you in the next lesson where we will be solving some more problems with multiplication. So have a great day, and I will see you soon.